Hello everyone, this is Professor Robert Solis. Welcome to this next video lesson. We are actually going to be talking about the iterative solution to this game, the Tower of Hanoi. So this first video lesson will describe how to solve this game using the iterative approach. Then my part 2 video is going to talk about how to solve this game recursively. But first we have to understand, how do we solve something like this from an iterative perspective. So let me go ahead and click Start. The reason why I like this particular approach is it has numbers on the disk, which is exactly how we are going to use this approach to help us solve this problem. The idea is to get all of these disks from pole A over here to pole C. And the goal of the part of the rules are that you cannot have a larger disk on top of a smaller disk. Only a smaller disk can go on top of a larger disk. And so that's why you see all of these from large, smaller, smaller, smaller to the smallest one. And you can see that they all have numbers. We're going to use the parity of each of these different disks to help us determine, should I move a disk from pole A to pole B, or pole A to pole C, or C to B, or C to A, and so forth and so on. Now, just to remind you, parity means, is the number of the disk odd or even? So we can just use like a modulus 2 to determine if whether or not a disk is odd or even. Okay, so let me switch back and forth over here between my algorithm, which is stated over here, of how we're going to move these disks. So it says disk 1, initial move that is, disk 1 is moved to peg 3 if n is odd. N is going to represent the number of disks. Well, as you can see over here, I've got a total of 5 disks. That means I have odd parity. Since I have odd parity, it says disk 1 moves to peg 3, and then if I did have an even number of disks, then disk 1 would move to peg 2 if n is even. But in this case, we have n is odd. So that means I'm going to move disk 1 to peg 3. All right, so let me go over here, and let me move disk 1. Let me say OK, and I'm going to move 1 over here to C. Okay, so that takes care of this first initial move. And then we have the subsequent moves. It says subsequent moves depend on the parity of the disk transferred in the immediately preceding move. Well, I just moved the disk that has odd parity. So it says if it's even parity, no. This was the one that I want. If it's odd, if its parity is odd, yes. The next transfer will be between pegs that are both different from the immediately preceding destination peg. Okay, so this is the destination peg. So the next move will be between those that have nothing to do with the destination peg. That's what this is saying. Okay, so let's take a look here what I've got. And the destination of the move is such that a smaller disk is placed on top of a larger one. Okay, so in other words, what I'm going to do here is I'm going to move this. There is no disk over here, so the move is between pole A and pole B. So I'll just take this guy and click it, click over here. Okay, good. So that has taken place. Let me go back to my algorithm. And what does it say? Okay, subsequent moves depend on the parity of the disk that was just transferred. Oh, well, I can see here that the disk that was just transferred was the number 2, so that's an even parity. All right, so what does that say? Okay, so if the parity is even, yes, that's what we just did, then the destination peg in the next move will remain the same. Oh, okay, so the destination is this pole right here, so we know that. All right. Let me see, will be the same. Okay, and the next disk will be transferred from the peg that was not involved in the immediately preceding move. Okay, well, let's see here. I moved from this pole to this pole. That means that this one had nothing to do with the preceding transfer, which was to move 2 from here to here. Okay, so it says that this is the destination, and I have to deal with the pole that had nothing to do with the transfer. That's this guy. So I'm moving from here to here. So I'll just click this guy over here and put it over here. Okay, now the parity of that disk that I just moved is odd. All right, so since the parity is odd, what does it say? Okay, the next transfer will be between the pegs that are both different from the immediately preceding destination peg. Okay, so this peg was the destination, so now this is not going to be involved in the transfer that I'm about to commit. All right, so what am I supposed to do? All right, the direction of the move is such that the smaller disk is placed on top of the larger one. Okay, so I know that this has nothing to do with my transfer. This is the smaller disk right here because this one's got nothing. So I'm going to transfer them from here to here. All right, now that I've done that, the parity of the disk that I just moved is odd. So I'm back over here at this. Okay, the next transfer will be between pegs that are both different from the immediately preceding destination peg. Okay, this was the destination peg. So that means the transfer is going to occur from either A to B or B to A. All right? And so what do? The direction of the move is such that the smaller disk is placed on top of the larger one. All right? Well, the smaller disk would be this guy over here, number 1. And so I'm going to take this guy over here and move it over here. All right. The parity of the disk that I just moved is odd. So we're going to do this again. The next transfer will be between pegs that are both different from the immediately preceding destination peg. Okay, so the destination was this pole right here, so that means the transfer will be between these two. And as you've already seen several times, it's going to be the smaller disk is placed on top of the larger one. So the smaller disk gets placed on top of the larger one. All right, the parity of the the disk that I just moved is even. All right, so what do I do over here? If it's even, the destination of peg and the next move will be will remain the same. Okay, so since this thing is even parity, this is still going to be the destination of a disk transfer from A or B to this guy over here. So what does the algorithm state after that? And the next disk will be transferred from the peg that was not involved in the immediately preceding move. All right, so go back over here. As you'll recall, the 2 was over here. I moved from here to here, which meant that A was not involved in this process. I know that the destination is here, and so the pole that was not involved in that previous exchange was pole A. So I'm going to take this guy over here, and I'm going to put it over here. All right, so the parity is odd, which means that, go back over here, parity is odd. The next transfer will be between pegs that were both different from the destination. Okay, that means it's going to be between here and here. And what does it say? The direction is such that the smaller disk is placed on top of the larger one. Okay, so if I go back over here, go back over here, it looks like this is going to be placed over here. Now the parity is even. That means the destination is going to be over here. I'm going to be moving a disk onto this pole. But how's that going to work again? Okay, so let's see here. The destination will be the same. The next disk will be a transfer from the peg that was not involved. Okay, so the peg that was not involved was this one, right? Because I moved the 4 from here to here. This was not involved, so I'll take this guy and put it over here. All right, that's an odd parity. So as you can see over here, with an odd parity, we're going to be transferring will be between the pegs that were both different from the immediately destination peg, and we're moving the smaller on top of the larger. Okay, so we're going to move the smaller on top of the larger, okay, like that. That's an even parity. Okay, so even parity. The destination is going to be the same. Okay, so we're going to move a disk onto here, pole A, and it will be transferred from the peg that was not involved. Okay, so let's see here. I moved a disk from here to here. This guy was not involved, so we'll take this guy and put it on top of here. Ah, that's odd parity. All right, so forth and so on, right? So this is the process that you go through when you are trying to solve the Tower of Hanoi problem iteratively. You're either going to consider a disk that was even parity or a disk that was odd parity and move appropriately. Okay, so let me run this program and show you this particular solution. This is not this is not the solution, this is a solution. The number of disks on the first pole. Let me just say that I have 5 poles. Okay, so that's an odd number. Now, one of the options that I'm giving is to look at this step by step. All right, well, the first thing that you'll notice is obviously I can't have pictures of disks, but I have the numeric values of the disks, similar to the previous page that I have over here. Each of these disks have numbers. Same thing over here. Those numbers represent the size of the disk, 5 being a larger disk, 1 being the smallest disk. And yeah, I want to continue step by step, so I'm going to say yes. Press enter. Now you know that the initial move, according to the algorithm, let's take a look at this over here. So let me put this over here. Actually, let me see if I can just make this smaller. And I'll just go to properties and make the font a little bit smaller here. Let's see if that helps. Oh, good. That does help. All right, so what do I have over here? It says, actually, I'll just move this over here. The initial move is to move disk 1 to peg number 3 if it's odd. Yep, so we have an odd number of disks. So I'm going to continue, then we press. And so notice what we've done. We've taken that 1 from that first column, which is column A, and we've moved it into column C. All right, yeah, let's do the next move step by step. And it looks like since the parity of the disk that I just moved is odd, right? That's odd. So the next transfer will be between pegs that are both different from the immediately preceding destination peg. So I moved the 1 peg from here to here. That's the destination peg. So what I just read is that the move is going to occur from the 2 poles that are different from the destination. Well, A and B are not the destination. C was the destination. So the transfer is going to exist from A to B or B to A. Now what does it say? The direction of the move is such that a smaller disk is placed on top of a larger one. All right, so this one doesn't have any disks, so the 2 is going to move over here. So when I press enter, you see that the 2 moved over here. Now the disk that I just moved is even parity. And you'll recall over here, even parity says the destination is going to be the same. So I'm going to move a disk onto the one that was the destination for my even parity disk, and that's this guy over here. All right, now what's the next thing? It says, and the next disk will be transferred there from the peg that was not involved in the immediately preceding move. Okay, I moved the 2 from here from A to B, which means C had nothing to do with that previous transfer. So therefore, this is the destination. That 1, which that column right there, had nothing to do with the previous move from one pole to the next pole. That's going to go on top of here. So if I push Y and I press enter, you see the 1 was transferred on top of the 2, and so forth and so on. Right? So we keep on doing this again, following these rules. If the disk that I just moved was odd parity, I do this. If the disk that I just moved was even parity, then I do this. And so if you want, I could just simply press Y and then continue. You can see the progression of the disks being transferred from one pole to the next pole. And of course, the goal is to get all of the disks onto pole C. No larger disk can rest on top of a smaller disk. All of the smaller disks must rest on top of a larger disk. Okay, so this is it right here. So I transfer the 1 over here, press any key to continue. Okay, so we're done. So I have a program here that solves this Tower of Hanoi problem iteratively. Let me run the program again, and I don't have to show you step by step. Let's say that I have 7 disks, okay? And do you want to do it step by step? No. So it'll just simply go through all the steps really quickly and then show you. If you wanted to, you could scroll back up to see step by step how all of this occurred. And I'm just going to the end to show you the solution of moving all the disks from A to C. All right. Now that was an example of odd number. Let's try an even number, like I said, 4. Right? So I press enter. Let's move all of these over here. So if I say, do I want to do step by step? No, I don't. And so it goes all the way over. And again, you can see what this looks like. It looks like I'm moving the first disk. What am I supposed to do? Disk 1 is moved to peg 3 if it's odd, and disk 1 is moved to peg 2 if it's even. So disk 1 is moved to peg 2, which is B, if it's even. So I have an even number of disks. That's why I moved 1 to peg 2, and so forth and so on, following the subsequent moves based on what we've done before. Okay, so now let's talk a little bit about the code. All right, so the best thing to do is to create functions to take care of the job of displaying the array. So when I run this program and it displays the array, as you can see over here, oops, sorry, if I click on this guy, and if I say, I want 5 disks, okay, this is displaying the array. This is displaying the array, which is nothing more than a two-dimensional array of values. And so as you can see over here, close this output panel. As you can see over here, I've got my two-dimensional array. So the pole array represents column A, column B, column C, and all of the rows for that particular pole. Now, I don't know how many disks I'm going to require, so what I did is I just simply said, okay, the number of disks is equal to 100. Right? It's obviously a larger number than I actually need, and you'll notice over here that I have the row size and the column size. I am telling the user, you've got to give me a certain number of disks from 1 to 9, because, as you can see over here, my row size is 9. That's really the height. The column, I have a total of 3 columns, column A, B, and C for the 3 different poles. And so I'm simply going to use a two-dimensional array to keep track of the disks on a particular pole. The setup array, well, that depends on the value that you gave to me, right? So if the user gives me 5, then I know that I've got to put 5 disks on that pole A. So you gave me a number of 5. Okay, I've got to put 5 disks on pole A. So I'm setting up the two-dimensional array. So let's do that. Let's go to this function and stop the program to see what it does. So I go over here, the bottom of my program setup list. Here we go. Okay, so I'm going to stop the program right here so we can see what this looks like. Actually, I think I could stop it right here. Run the program. All right, let's type in the number 5, press enter, and so we're stopping the code here. So here's my two-dimensional array. As you can see, so nothing has been initialized. So the first thing that I'm going to do is to set up the array, and so let me say continue. And so it looks like over here I've got 0, and then if I say continue, and then it looks like over here I've got a 0 on column number 1. So this is index 0, index 1, and then of course I have to do this one more time. And so now all of these have been initialized, and so then I can keep on going through this, as you see here. Keep on going through this. Now for the next row. Okay, so let me see what I've got so far. Okay, so for this particular index, I've got for this particular two-dimensional array, I've got values, and then there are additional values for every single row and for every single column. And that's what I'm going through right now. So let me see if I can jump out. So I'll step out of this function. In fact, let me just do this. Let me take away that break. I'll go back over here. And let's see here. So over here, I called set up the array. And let's just stop the program right here. All right. So now, if I take a look at this two-dimensional array, as you can see here, because I entered a total of 9 disks, you see that the array has been initialized. Actually, how many disks did I enter? Oh, 5, sorry. But what I did was I took this array, which is fixed, and I initialized everything. So everything is given a 0 value for the 3 columns and the 9 rows. All right. So now that I've done that, we're going to establish the disks on the first pole. Well, that's going to be based on the number of disks that was given to me by the user, and then whatever that counter is, I'm going to subtract from it. I'm going to place into this pole array. So let me just stop the program over here. I'll say continue, and now we can take a look at the two-dimensional array, and you can see what happens. So now remember, this is upside down because 0 is the bottom row, 1 is the next row above it, 2 is the next row above it. That's why you see these numbers 5, 4, 3, 2, 1. But really, this is upside down. 0 is the lower left-hand corner of the Cartesian coordinate, say, for example. So everything looks upside down, but as you can see, the 5 disks have been placed there. Okay, now let's go ahead and display those. And so if I were to continue, and so now it's going to display that. Let me just simply go over here. Here's the display, which is the 3 poles and the 5 disks. So So we've done that. And so now it's time to move the poles. Well, that's going to be based on, as you can see here, until we have all the disks have moved. Okay, so as long as the pole array for the number of disks minus 1, so for this particular index, well, let me see here. So that the number of disks is 5. 5 minus 1, that's 4. So I'm saying for the pole array for the row 4 and for the column 0, 1, 2, so that's the third column, as long as that's not equal to 1. So in other words, what I'm trying to do is this. Let me go ahead and run the program. And go back over here. Okay, so I don't want to go step by step. All right. As long as this item is not 1. Okay, so let's see. Let's go back to the beginning over here. Is this item for this particular row, this column 1? No, it isn't. Okay, continue. Is this item over here 1, which is the one above 2? No, it isn't. How about, okay, this is 2, then that's 1 over here. Is that 1? No. So forth and so on. You can see that we keep on going. We keep on moving disks because this item over here is not 1. Finally, when I move the 1 to this particular row, this particular column, that one is 1, so now we've reached the end of our program. That's basically what this while statement is asking. Have you moved that disk, the one disk, to that one position right here that indicates that all of the disks 5, 4, 3, 2, 1 are stacked on top of each other? Because if you haven't, then you have to go through this process. Remember what that initial move is? Well, if it's even, you do one thing. If it's odd, you do another. That's what this does, right? And then we have to determine, well, what is the parity of the disk that was just moved? So the moved disk, if it has odd parity, then we follow that algorithm of what's the destination pole. And then if it's odd, if it's even parity rather, then this is what we do over here. Again, going back to the top of the program for our algorithm. So I'll let you go through this and see step by step how this works out. I'm just simply following the algorithm based on the top of this code. All right, so then once we've done that, once we've moved stuff, we have to establish top disk values. So I have a function that takes care of that. I'm going to determine the parity of the disk that was just moved. So if the disk value mod 2 is equal to 0, then that's an odd, or that's an even parity for the disk. So I'll say that 0 represents even, 1 represents odd. So I determine that. And then I ask the user, hey, do you want to see this step by step, or do you just simply want me to display the data? Based on your decision, one of these statements are going to execute, either the if or the else portion, and then that's it. Okay? So your job is to go through this code, making sure that you understand it. I'm going to give you access to this. Move step by step. You are basically solving this problem iteratively using this algorithm. The next video, I'm going to show you the same exact problem, but we're going to show you from a recursive perspective how to solve this. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.